Ignition sequence start. 6, 5, 4, 3, 2, 1, 0.
So the first group of hardware we're going to talk about here is just is a whole collection of hardware, actually, that you see on the table behind me here. We call this the suite of hardware the Biological Research in Canisters, or BRIC. BRIC is actually can be flown in several different configurations, but fundamentally the important thing about BRIC is that we start off with something that an investigator is used to working with, a petri dish. There are a lot of biological investigators who do their science in petri dishes. You might think, oh, well, it sounds like the kind of thing people are looking at bacteria or fungi might work in a petri dish. But actually, even larger organisms can be put into petri dishes. So this is here to talk a little bit about kind of just the design philosophy, which is you start with something that the investigators are already familiar with. That shortens the amount of time it takes them to kind of modify what they're used to doing in the laboratory to something that they're going to do in space. And the goal has always been to just essentially wrap a box around their science, as we like to say. Now in this case, the box isn't a square box, it's actually a cylinder, but you can see that in the simplest of cases here, this is the so-called BRIC 60 canister. And it's named that, you know, it's not very adventurous, but it's a 60 millimeter petri dish, fits inside the canister. You can see there's a stack of petri dishes inside this canister. And this is very simply got some Teflon bumpers on it to keep it from rattling too much during launch and landing. Closes those up, and then it has a lid that screws on the top. But even though that seems fairly simple, there actually is a little bit of technology in this, and specifically the venting system on this. As you can imagine, we can't have a canister that's completely sealed up, fly in space. We have the risk of depressurization events, for example. Well, you can actually fly something that's sealed like that, but if you do so, they have certain structural requirements that we won't go into today. But if you have a vented canister, it has to be vented in a certain way as well. So this has actually got some tiny vents. You probably can't see them, but along the edge here there are 4 tiny holes. And each one of those tiny holes, instead of just being drilled straight through the lid and to the inside, actually goes into this knob that you see on the bottom of the lid. And that inside that knob there is a passageway that makes 3 right turns before it finally exits into the canister. We do that because if you make 3 right turns, you pretty much preclude any light entering through the vent. And so if you have an experiment that's growing plants, for example, in this canister, plants are both phototropic, meaning that they respond to light as a stimulus, and also gravitropic, meaning that they respond to gravity as a stimulus. If you're trying to isolate the gravity stimulus, you need to get rid of the light stimulus, and so that's the way in which we do this in this very simple case. So BRIC canisters have gotten more complicated over time. This is just a bigger version of the same canister, only it takes a 100 millimeter petri dish. We had to go to a bigger petri dish because we had an experimenter who wanted to fly the chrysalis of a tobacco hornworm moth, which is about this big. Fits nicely in a 100 millimeter petri dish, but it didn't fit at all in this little petri dish. So we had to build a bigger canister. Again, fairly straightforward. We had another investigation that wanted to fly on the space station Mir, and so we built yet another canister that had a very specific atmosphere inside of it. You can see that there's a seal on this end and another quick disconnect on this end. We could put a couple of syringes through there and flow air through there of a known composition with a known amount of nitrogen is what we were looking for in particular in there, and then seal it up and allow this thing to fly. Now this one does in fact seal closed. Remember I mentioned the other ones have vents. This one seals closed, so it's actually a much thicker walled, more robust canister so that it could survive potential depressurization event. So bricks, as you can see, all look like they start off life as a petri dish, but then we've wrapped some sort of an aluminum can around them. From here, we'll be talking in a minute about the most complex of the bricks, which is what flew on STS-135.